Thank you everybody for joining us today. As you're coming in, continue to say hi in the chat. Let us know where you're tuning in from. Couple of quick housekeeping notes. We got a couple of great guest speakers tuning in today. I'll be monitoring the chat. If you have questions for them as they're delivering their presentations, drop those into the Q&A box, and I'll pose those questions to them at the end of the session when we get to our Q&A portion of today's presentation. If you drop things in the chat, I'm going to try to keep an eye on that too, but I may miss it. Usually Cassie is here to help me keep an eye on chat versus Q&A. But if you want to make sure your question is caught and seen, use that Q&A window in the menu bar. To get us started today, we're going over discussing monitoring and data management, looking at SCADA systems, their capabilities, and how you can make optimal use of data at your facilities. Joining me today is Paul Morlock from McHenry Automation and Mike Lund from Xylem. We'll be covering different aspects for smaller plants and larger plants that already have automation systems in place, and plants that are looking to implement automation as a starting point. A little bit about CDAC's program here. We are an applied research program at the University of Illinois based in Urbana-Champaign. Our goal is to assist buildings and communities in achieving energy efficiency, reducing money, and becoming more sustainable overall. Our overarching mission is to reduce the energy footprint of the state of Illinois and beyond. The program here today is just one of many programs we have that helps to work towards that goal. So a little bit about the IEPA Public Water Infrastructure Program that we are part of and is bringing this presentation to you today. We've partnered with the Illinois EPA Office of Energy to provide training and no-cost energy assessments and technical assistance for publicly owned water and wastewater facilities. As part of that program, we offer the no-cost assessments, which at the end of that assessment process, you'll get a comprehensive report listing potential savings, estimated economics, and funding sources to help you fund those projects and get them off the ground. And we also bring operator continuing education programs like the one today. If you are interested in an assessment, you can go to our website, www.smartenergy.illinois.edu/water, and there's an application button there that will get you started in that process. Why would you want to complete an assessment? If you have an older existing system or you haven't had a previous assessment, we can identify missed opportunities. We can help you plan for future capital improvements, uncover potential possibilities that you haven't maybe thought of yourselves yet. And for those proactive operators that are always thinking of how to become more efficient or improve their plant's treatment processes, we can offer that support for your ideas to help you identify what are the savings potentials, what are the payback periods, to help you really drive those ideas forward. What if you have a brand new plant or it was recently upgraded or had a renovation project? Budgets are tight. We always know that trade-offs are made in processes and things to fit within those tight budgets. So there's always something that's left on the table where there's potential improvements that can be made. So we can help you identify anything that may have been left on the table or maybe wasn't considered in the original designs to help you plan for future opportunities. We can also help if you're in the midst of a current upgrade, plan for future projects beyond the scope of your current project. And there's always new technologies and processes in development. We're keeping an ear to the ground for what those potential processes and technologies might be. So maybe we can bring new ideas to you that you aren't familiar with. And as always, we're always keeping an ear to the ground as well for funding opportunities. So if nothing else, we can help connect you with utility incentives, funding programs, low interest loan programs, and those sorts of funding opportunities. So once you apply for an assessment, we have an initial application form that just goes over the pre-qualifications for our program. You apply at, it's our old website address, but smartenergy.illinois.edu/water. You do have to be a publicly owned treatment plant. So those of you that are under American Water or one of those private companies, unfortunately, this program does not cover those facilities. But then you have to agree to allow us to come out on site, We can do remote visits. Back during COVID, we started doing that as a potential method for doing site visits. But most of the time, we're coming out on site. We're physically seeing what you have at your facility. You got to be willing to share facility information with us so that we can do an initial benchmark, let you know where you stand in relation to other facilities that we've been to. And you have to agree that we're going to share that final assessment report with the EPA Energy Office as a means of tracking the efficacy of our program. It's a non-regulatory office, so there's no concerns about permit violations or catching something or anything like that. We're just here to help you identify opportunities and help you achieve those opportunities. The next step, we're going to work with you to collect data on your facility. For wastewater facilities, we need to collect your discharge monitoring reports. We can do that in our office using the State Central Database. So we try to make that process as easy as possible. For utility bills, if you're on one of the major utilities like ComEd or Ameren, we just need the account number, and then we can pull all the data history that we need to make that as easy for you as possible. If you're on a municipal or co-op program, then we're going to have to work with you, your city clerk, whoever is managing those utility bills to get the data that we need. We try to collect 2 years of data history. That way, if there's an oddity that comes up during 1 year, process breakdown or something that changes your benchmark, we can account for that and go with a more consistent year. But we're always here to assist. So even if you're not looking to do a full energy assessment, if you're just looking to apply for funds for a single project, say you're replacing a pump or aeration equipment or something like that, feel free to reach out to us. We have a technical assistance program that's a lighter version of the assessment program that just helps connect you with funding resources and opportunities. So we can do that for you as well. But once we have all that initial information together, we'll benchmark your facility, and then we'll schedule the site visit. Those site visits usually take a couple of hours, depends on the complexity and size of your plant. If you're a fairly simple aerated lagoon, we're probably going to be there about an hour or so. Some of the larger, more complex facilities we've been to have taken 3.5 hours to get through the entire process. But we're just walking through the facility. We're documenting the equipment that's there, the processes that are in place, the condition of the equipment and processes to help us formulate the ideas and efficiency measures that we're going to include in your report. And once we conclude that site visit, we'll review those opportunities with you, provide you a chance to give us feedback on what you want to see in that report so that we can tune it to what you want to see. For today's webinar, though, we're going to get into SCADA systems and data management for wastewater utility facilities. We're going to kick things off with Paul Morlock from McHenry Automation. And I want to thank you for joining us today, Paul.
Thanks, Sean.
Just provide you control of the slides there.
All right. As Sean said, I'm Paul Morlock with McHenry Automation. Been working with McHenry for 11 years. Just going to go through just a quick information about our company and then get on to today's topic. We're a St. Louis-based company founded in 1993 with currently 25 total engineers between our St. Louis office and our newer Kansas City office. We've had several certifications, one being our CSIA certification that we have maintained. It makes us one of 70 companies in North America that have that status. We're also partnered with Rockwell, Aviva Wonderware, and Ignition for all their integrator programs. And we've started building up our Siemens, FANUC experience as well, and our newer business information systems and cybersecurity programs that we've implemented here in the last year or so. And just we maintain all these partnerships with the software companies that we use, mostly to make sure that we're deploying the latest technology to our customers and maintaining the standards that those companies like to see in their and their software as well. So, that our specific experience in the water industry is over the last 25 years that we've been doing water work. We've racked up over 55,000 hours and over 200 projects, just helping out all across North America in water supply and wastewater treatment, whether in the process industry or city usage as well. Today, I'm going to go through a basic SCADA model for a wastewater site, whether it's a small one that doesn't have anything currently, or even just coming into an existing site and helping out a little more. We'll go through the importance of SCADA for a wastewater site and how to use it to increase the performance either just of your equipment or of your energy usage. And then just last, I'll cover some of the key data points that we use with our customers to accomplish all of that. So for the basic layout of a SCADA model, we'll start at level 1 with the plant devices, which will be all the pumps and valves, transmitters, all the sensors that you have that gather data for your site and that you may be going out and looking at manually, or you may already have a PLC or multiple PLCs on site, but you tie all that data back into the controllers, and you may have separate, several isolated networks on site due to geographic location, whatever. But some of our customers, we've used radios and fiber to tie back all those individual systems to bring everything back to one place up into the supervisory network for HMI control from one central control room, and that tie it all back into a historian. And we've also used call out software to help for the off hours when the site is not manned, to notify of key alarms that need attention. So the importance of SCADA for a wastewater system is through the HMI system will allow operators to have all of the data back at one spot, to where you can make sure you get more informed and quicker responses, either based on operator interaction, or we can go as far as using the controller to have automated solutions for key situations that happen in the plant. And as I mentioned before, we can also simplify the control of your plant by bringing the different areas of the plant that may not be connected. You can tie them together and let the system react to itself, or just allow the operators to not have to travel out all the way out to a lagoon, something to see what's going on. We can also use the data we collect via historian to make automatic reports, so that we can help alleviate some of the problems of making sure that the reports get generated on time, or that they're accurate. And when we let it happen automatically, it can reduce a lot of that stress. And we can also use our historical data to just help validate some of the manual data points that get collected throughout the day. So I've included a couple screenshots of high performance HMIs using Rockwell's Plant PAX that I just walked through some of the features that we've included to make life easier for operators and make sure they get the information that they need efficiently. And these screens are developed using the ISA 101 standard, which basically has a grayscale to show the pumps and valves that are not running are the dark gray ones. They turn white when they're running or open. And then you only start to see color when something goes wrong on your site. So with this system that we have set up here, like we're looking in Headworks, but you can look at this screen quickly, see that something seems to have happened in the sludge treatment area. So you can quickly navigate through the screens, and 2 button clicks, you can see that your digester are where your issue is, and you've got you can see that your tank is full. So, but having you can even update old sites to have this kind of standard has really helped our customers remove some hiccups that they've seen in the past of getting lost kind of in the extra color and animations that some of the older systems that we've seen have implemented. And then we've also, once you've added in a historian, we have access to putting trends into the HMIs as well. And you can, on the left, we have like running data of pH and temperature in your wet wells. And you can see down there, there's a dashed line that shows you when you've gotten out of spec. And you can use that and go dig in deeper to your historical trends on the right and put multiple tags for your system to help build a profile of why your system behaved the way it did. And it can help the operators take corrective action and even start to implement some programs to prevent it from happening in the future. And we also, in this system, have it built in to allow you to do your reports all from the HMI. So this Excel reporter that we're using here has the ability to, on the left, you can click this button, Excel reporter button, and it lists all the reports that we have pre-programmed in that will just generate when you click on them and set your time. And you can print these out, export them so that you can send them off where they need to go. But not every data point in your plant will always be available in the SCADA system natively. So we do offer the ability to manually enter data. So on the right side here, I have like the daily weather that you don't normally get built in because we don't like to attach SCADA to the internet. So you can punch this data in here, and then it goes into the historian, and it'll be available for any of the reports that you need it in. So you can do other manual test points in your plant can be fed into this as well. And then moving on to performance, we can use all the data from your devices that you've got tied back to the PLC to establish thresholds of normal and abnormal equipment behavior, and set it up to either send you notifications as alarms on this system, or we can even set it up to do emails out to like the maintenance staff to let them know that a device is starting to behave strangely. And a lot of that can be set up just from like simple faceplates on your system. Just put in set points, put in time frames for how long it needs to be in alarm condition before we really need to care about it. And then over time, after collecting all that data, we can actually build in predictive maintenance. So we can set schedules for when equipment should be taken out of service and maintained before we get to a unplanned downtime situation. And you can also, we also keep track of, use all this data to keep track of performance of equipment just from how well your plant is operating. So on the right here, I showed trends of flow control through the lift station, and you can see how quickly the system reacts and how well it reacts, and make adjustments to the individual pieces of equipment here That way, like if this was a chemical dosing situation, this does not look great, and you would be overdosing quite a bit, and so it's not cost effective for your chemicals, and it also not good for your quality. So seeing data like this and then allows you to make those adjustments and for the future, and hopefully keep your site consistent and as cost effective as possible. We can also use information like this as well for energy efficiency. So once you get feedback from all of your pumps, which are a lot of times the biggest energy consumers, that you can build a profile for what pumps use how much uh, energy. And we've done with a lot of our water supply companies is checking what time of day it is to compare to peak time usage, and then building a profile of what pumps, either they're on VFDs or motor starters, that should be running at a certain point of time, depending on how big of a pressure correction we need. So a low correction could just mean run a small VFD. That way we use a little bit of energy instead of hitting it with a pump that's way oversized for the time of day it is. But then when you get into nighttime and low energy usage, it may be just fine to start up a bigger pump and let it correct the system faster. So all stuff that you can work, we'll work with the sites to optimize for them. And then just the last part here is just some of the key data points that we have monitored throughout the years that has really helped us is flow rates and volumes for making sure you've got consistent flow through your system, and it allows us to detect any sudden changes that the operators might need to know about. We can also, as I mentioned before, the chemical dosing and usage is getting feedback from the system and adjusting our dosing based on how well we're performing really helps trim down on excess cost of chemicals and improves quality quite a bit. And then for the biological process, we measure things like dissolved oxygen, pH, and temperature. That way we use that feedback to adjust our aeration rates. That way we're not doing too much or too little there. And for sludge management, is a lot of levels for our clarifiers and digesters. That way we make sure we're processing our solids correctly. And then last one being energy consumption, which I covered before, was make sure we're getting the current feedback is the biggest thing there, so that we can make sure we know how well our pumps are performing. So. All right, that's everything I had for McHenry. Thank you guys for your time, and then I'll stick around for questions later.
All right, thank you, Paul. Next up, we've got Mike Lund from Xylem. Give you control of the slides here and take it away. Oop, you're muted, Mike. You're muted, Mike. You unmuted and remuted.
Okay,
There we go.
I guess I'll just hold this down. I can't get the thing to pop up. I'm Mike Lund. I've been with Xylem for about 4 months now. I'm typically better with technology than I was just a moment ago. I've been in the industry about 46 years, done everything from being an operator to a utilities director. And I'm going to talk a little bit today about your data. And first, I want to tell you a little bit about Xylem. Well, What happened?
The are you having to hold the space bar down to
Yeah,
talk? I think it auto advanced the slides.
okay. Can you put
Let
them back
me,
up? I
yeah,
am
just a
unmuted
sec.
now. The mute thing popped up and I unmuted now.
Okay. Get us back to
I'm
where we
having fun
were.
today, boys. So I work with Xylem. I'm part of the digital solutions team. Go out and assist plants with digital transformation and understand what's going on in the digital space today. And so, is the slide deck back up? Digital space
There we go.
today. There we go. Xylem's a fairly large company. You've probably heard of us. We represent
I
I don't
give you
know.
control again. There we go. It zipped through everything and removed your control from you.
We're having this is just wonderful. So Xylem's a fairly large company. We're in about, I don't know, 150 some countries. One of the things you'll notice that we have a lot of brands. Probably most of you are familiar with Flight or Census or Leopold or YSI or Sanitaire. We have a number of brands. Most recently, Evoqua joined us. And so we're a global company. See if I can actually advance the slide. We're big on corporate social responsibility. For the last 11 years, there's been a lot of volunteer hours donated. We've been in more than 70 companies with our Watermite project and affected many lives through our volunteer actions. All of us employees are allowed to volunteer and encouraged to. We have some strategic nonprofit partnerships with global and local NGOs all over the world. And we help people in need to clean up local waterways and other global water challenges.
Just a sec, Mike. I think it's sharing your presenter view
Yeah,
instead of the.
it is. It
Let me
is.
let me make sure I share the right screen here. There we go. Now you should be set.
That's all right. So as a digital solution provider in Xylem, we realize that many of us have problems in the industry, many utilities, many water plants, wastewater plants, whatever. And some of it's because the weather's changing and impacting us. We have these intense rainfalls. I live in Michigan, and recently, like the west side of the state, east side of the state got hit with, I don't know, 8 inches in just a few hours and other things. Over that's happened to them like 3 times in 5 years, and they're having problems with that. Of course, budgets are unlimited. No, they're not. They're very constrained. We all live with that. There's things that we need to do, things we want to do, things we should be doing, and we have to make them choices every year when we put together a budget. Of course, a lot of unknowns out there because the regulations continue to change, and of course they ratchet down the regulations. Our effluent limits or our drinking water limits get more refined and tighter all the time. We have new chemicals, new toxins to deal with. In the old days, it was mercury and PCBs. Now it's looks like it's going to be like chlorides, PFAS, 6-PPD or whatever it is, 6-DDP. So we have all those problems to look forward to. That didn't work. Took away control again, I think. Oh, no, there it went. So as we run our facilities, we run our utilities, we have a lot of data. And with the changes coming today, especially with AI heading our way, and if you don't know that, there's going to be an AI revolution if you're not in the middle of it already. It's going to be much like an industrial revolution or back, I don't know, in the 80s when people said personal computers were just a fad, or in the 90s when they said the internet was just a fad, or even in 2000 when they said cell phones, you know, these smartphones were just a fad. Things come at us. The technology changes. And this is a good time to sit back and take data inventory of what your system has. We've talked about a SCADA system, but you know, when's the last time you looked at it? Where is that server? Do I have a backup? What's my plan if it goes down? All these things you got to think about your SCADA server. And then you have your things that are probably not behind your DMZ, your lab, your regulatory reports, asset management things, and other. And we're seeing more and more utilities falling to hacks and these people that lock them out of systems. And then the other thing, like we can export something from SCADA, but then we got to combine it with our lab to make a regulatory report. So one of the changes, big changes I see in many facilities is something above this, a layer above all these data sources that brings them together for reporting, visualization, using AI to determine things. And that's all going on. So you really need to take an inventory and see what data you have. And don't just do it from your desk. Go out and talk to other people in your organization, because sometimes you have data and people are using things you don't even know of. I've had, working as a utilities manager, people using spreadsheets that they saved to their local drive, whereas we were updating them out on the network for everybody to use, and couldn't figure out why everything wasn't working. Is because they were using personal copies that were outdated instead of the live copies we want everybody to use. So take a time to look at your data, who's using what and how they're using it. And then after you know where your data is, think about all the problems that are keeping you up at night. I mean, do you have problems with your capital expenditures? Is your capital budget not in line with what the city would like it to be, or the township, or wherever you work? Or do you need to optimize some systems? You're not running as good as you could. Of course, operation reductions, and sometimes it's not even a reductions. Most plants I go to, their biggest problem right now is hiring people, right? So don't really need the operations reductions. We need to know how we can manage with what we have. Asset management in some states now is included within permits. And we know that our assets in most cases are aging and we need to take care of them. And of course, the big thing that'll keep you up at night is regulatory compliance. And some system went down. How am I going to comply? What am I going to do next week? So once we decided, you know, what our key issues are, we can move from there. And so, like I said, the first step, inventory your data. And then the second step, integrate your data. And once it's all integrated somehow, some people are calling these data lakes. Some are just using aggregators to bring them together. In my case, in digital team, support team with Xylem, I represent a product called Xylem View by GoAgua that brings all this data together and makes visualizations and reports. And then once that's done, then you can use AI, and it's going to be over the next few years. If you haven't seen it, AI is going to grow on you. If you're running an updated version of Windows today, you have Copilot down on the side, you know about Google's Gemini, and there's all kinds of AI coming out there. It's going to be the next revolution. It's going to help us with all our, well, paperwork and process control for the most part. So once you inventory your data, think about how you're going to integrate it all. Probably going to need a software platform or something. Okay, so let's say your biggest problem right now is an operational problem. Say it's aeration. And you've done your data, you know what you got. And what am I interested in first? Right now, do I just set my blowers and let them run? Am I interested in going to manually turning them up and down as the flow changes? Do I have a DO meter? Do I need a sensor? If I have a DO meter, then can I manually control my blowers better? Do I need a PID loop to do that? Of course, then from DO, if you want to save another, on the average 15%, you can go to ammonia control of a secondary system. And then the ultimate way to go is with a digital twin that makes real-time recommendations based on the flow loadings and more sensors, influent and effluent sensors of COD, ammonia, and other things, depending on what you're trying to control, what your permits limits are. Your BNR plant, maybe that has to do with phosphorus. And then the next question, do I actually have the data to do what I want to do? And if I don't, what do I need? Do I need more sensors, influent and effluent, ammonia, DO, whatever that sensors is? Do I need a little more lab data? Do I need to know what my volatile solids are? Do I need to know better control on wasting? Do I need a PLC? Maybe I don't have these hooked to anything and I only have a manual control knob out in the plant that I can turn them up and down. So as you think through all these things, think about where you're at, where you want to head it, what data do I have, what data do I need, and possibly what data would I like to have. Sometimes that's nice too. And that's my short version of where you should go and what you should do with your data and where we're headed with AI. So thank you.
Thank you, Mike. Appreciate it. So if you haven't yet, you've got a question for one of our speakers, go ahead, drop it into the Q&A pane. One thing that I've seen going out on our site visits and stuff, Paul, you touched on it a bit with your layouts as far as color coding to highlight important alarms changes. But we go to a lot of sites where the SCADA system can be confusing, looking at historian trends and trying to pull out useful data and stuff. Could both of you speak a little bit towards how to take the information your SCADA has and make it something that isn't overwhelming, but actually useful?
Sure. Yeah. So, yeah, I think the biggest thing to do if you've got a system that maybe you just, like you said, you've got too much data all in the same place, is take a step back and maybe even just make simplified screens of what you really need. And that comes from sitting down with the plant, talking through what you want to get out of the screen. And then a lot of it comes from removing stuff. I mean, or like we said, making it grayscale. You don't need all your wells to be full with blue fill animation and have spinning stuff on there, everything that just distracts from what is really important for a site. So talking with an integrator and talking with other sites, kind of like Mike had mentioned, is a good way to remove stuff you don't need. And maybe you're just even getting the wrong data. Like you may have all the things in the world, but not the data that really gets you the goal you have in mind. So, like Mike said, adding new sensors can help with that, but you don't want to bring in too much to one area. So separating your screens out from a high level overview down to more detailed screens that are for specific areas can help with that as well. And they call them like a level 1, 2, and 3 screens, to where a high level overview, and then you have like a medium sized area that may encompass a couple smaller areas, and then you can drill down into the smaller areas at the third level as well. That way, as you need the data, you can go find it, but you don't have to see it all the time. And with trends as well, you can actually build in pre-built files so that you're not constantly rebuilding a trend and or have everything visible and say, like, what do I constantly need to check this pump's efficiency, right? So I already have pre-built trends that show the current that it's drawing, its output, the process variable for, let's just say, flow, already in and out of it. That way, I can just click on it and see it very quickly, see how it's been performing, and make adjustments if I need to. So.
Mike, any to add to that?
Sure. I think Wonderware and Rockwell both make another tool. Like with Wonderware, it used to be called iTrend, where you can get at your historian and make your own reports. More recently, I see people pushing their historian data out to someplace either local, on premises, or maybe into a cloud system where they can use other tools, Power BI or other tools to make reports as they need it. And the reason they do that is so they can integrate all their different data sources. They can take their historical data, they can integrate it with their lab data and integrate it maybe with their GIS data or their CMMS data. You know, that here's a pump, this is how it's acting, here's the work orders we've done on it. And, you know, this is the solids it's pumping. Maybe you can get in one report in one framework. So at a base level, you do it in your SCADA system, you can see that. You want to integrate it with other things, you have to push it someplace. You can do a full evaluation on your whole system that way. So just different ways to use your data.
Thank you. Another question, concern that comes up pretty frequently is data security, particularly when you're trying to pull in information from remote sites like lift stations. Some plants have remote stormwater handling facilities. How can they pull all that information together to a central place without exposing to public networks?
Well, from my experience with a lot of our customers here in Missouri, is that we use either radio or cell to handle that. If we're not going to use a direct fiber connection between sites, that obviously is a limitation there. But when we have a direct radio connection between sites or cell, that way, it's hard to intercept without really knowing what you're doing.
And when you use cell, do you use a VPN? Do you have the cellular network set up your own VPN for you to move the data over?
Yeah, it depends on the customer. That's we have done that in the past. The cell networks usually come from a bigger company, like that use the cell networks are bigger companies that have that structure across the US. So yeah, they have that all on their IT backbone and protected that way.
Right, Verizon or AT&T or somebody else, it will sell you a machine-to-machine cellular network, and for $500, set it all up for a VPN for your use, right?
Right.
Great, thank you. One of the screenshots, Paul, you had put up had like a dashed line indication of being out of spec.
Yes.
Are you seeing that more and more as a way of doing like preventative maintenance or things like that to maintain plant efficiency?
Yeah, we're seeing that. And like I've been putting that not even just in water, but some of the other industries that I'm going in, that we're putting the set point ranges down for where we expect to see things, setting up alarms if we deviate outside of that by like 15%, depending on the process. Sometimes it's a lot smaller, but we've even gone as far as for some valves of putting in timers to record. We know this valve is new and it can actuate in 2 seconds. And if we start seeing, travel times of like 5 seconds or so, we know something's maybe clogging up that valve or the actuator needs to get replaced. So we've gone that far as well to set off alarms and send out notifications to the maintenance staff to say, hey, go check that out next time that we've got downtime or something like that. So
Great. Something else about maintenance and managing labor and stuff. Some facilities end up with a backlog of alarms and things, and they don't know where to start with addressing those, particularly in some older facilities. Can SCADA systems and integrators really help to target, if you address this alarm, that has a cascading effect and addresses these other alarms? Are you seeing that kind of automation appearing in these SCADA control systems?
I don't know if I would necessarily say that we automate the clear up of it, but we definitely just from our process knowledge, we definitely sit down with our customers. And like you said, mostly for sites that are older and have just a influx of old equipment that's has or may not have been removed from the SCADA system, but has been removed from the site and can cause alarms and stuff like that. So we definitely do alarm audits with our customers, sit down, look at what all the alarms on the site, see if they're even necessary anymore, and help them look at the triggers as well to see if the trigger makes sense. Maybe we need to modify it because the plant operation has changed a little bit. And by maybe setting the control flow set point in and out of the facility alleviates a lot of the problems that we're causing because we're taxing the system more than we were before, which means we're operating outside of the old alarm set points. And then, so yeah, that can cascade down from there of clear out alarms that aren't really true alarms anymore because we've just changed the site profile. So it's definitely something I recommend. I've had some of my customers that I've been with for a long time. I try to have them sit down at least once and do this with me.
Hey, one final question I had about SCADA processes and stuff. One of the things we've run across with some of the more advanced aeration systems like ammonia-based controls is calibration of those sensors and detecting maybe they're getting out of spec or need to be calibrated. Can SCADA systems be used to help automate and kind of predict when that kind of calibration needs to be done to take some of that workload off of operators to just go out there and do it on a regular time basis to ensure those things are calibrated?
I don't have as much experience in that particular detecting out of calibration itself. I mean, you definitely can start to track your data from if you notice, hey, I'm starting to get to this reading doesn't seem right. And then if you start keeping track of when you have to go out to that device, you could put a trend together of it seems like I have to touch this thing every 3 months. So instead of waiting for it to go bad, you can set up a PM for it and say, all right, 2.5 months, I need to go recalibrate this equipment. But a lot of times the way to detect something like that would be to just have more than one of the sensor and compare them. So like some of my non-water customers use, if they have pH, they have 2 pH sensors. And if one of them starts to get out of spec, you know that one of them is wrong and you should go look at it. So, Mike, yeah.
Yeah, I think in a SCADA system, you can certainly set up an upper and lower range alarm if you think it's getting out of range. Like if your DO probe only goes up to 10, it's reading 12, you know, you have a problem. If it's sitting on 0, you might have a problem. That's one way to do it. The other way I see a couple different things. I see them using software packages to actually watch the meter and decide if it's doing what it thinks it should be doing. You know, at a higher level, AI is doing that in some cases. At a lower level, it's just based on plant conditions. I see most people in the smaller plants building a spreadsheet for, like if they have an ammonia analyzer for ammonia control, they'll build a spreadsheet where they'll keep track of how far it's in or out. When they put them in, they'll commission them with, you know, 5 to 10 different points, and they'll look at the line that they're on and build a regression curve for that. So they'll just track it like in a spreadsheet most of the time, what the value is, what the value they're seeing. And then they'll just use the SCADA system for alarms if it's out of the range they think it should be in. Say your ammonia is generally runs 2 to 6, they'll set it to, you know, give a warning under 2 and an alarm under 1 and vice versa. So I see a lot of that going on, and people, you know, scheduling time to take care of these things. When we think about our plants and the investments and the huge investments we make in them, you know, if you have a tens of $1 million plant, see a lot of people giving up on these sensors because you have to maintain them. So, you know, it's a $15,000 sensor that improves the efficiency of, you know, a $50 million plant. And that's the part I see most neglected in a lot of plants, is some of the instrumentation. We never used it. We just set our blowers on 6 and we called it good, right? So
I did have a question come into the chat. Does this help with outdoor hatch units? I'm assuming like the hatch DO probes.
when you're looking at DO probes, I found that one thing you want to check periodically is, yeah, you can build a spreadsheet to track them over time on how they're doing. But the biggest thing I see getting away from people is the 0 on them. Once in a while, you got to put them, you actually have to stick the probe in some water that doesn't have a DO in it to see where that 0 is at. Typically what I see for maintenance is, you know, the operator goes out once a week and cleans it or whatever. Maybe air calibrates it on occasion, or checks it with a portable probe that's been calibrated in the lab. But the thing I don't see is people actually checking the 0 on them. And some of the DO probes now, they got a cap you got to replace once in a while, and I don't see people replacing that. So certainly your SCADA system, you can set, you know, if your DO goes over 8 or under 1, maybe there's a problem with the probe if it never goes that way. So.
All right, great. I don't see any other questions that have come into the chat or Q&A. If anyone has questions for our speakers that come up later, I can pass along their contact information to you or pass along your questions to them. If you have questions for us about our program, interested in an assessment, technical assistance, funding assistance, please do reach out to us at cdac-info@illinois.edu or through our website at smartenergy.illinois.edu/water. So thank you all for attending today. Thank you again to our speakers for helping. Any final thoughts before we let everyone go?
I hope just thank you very much, guys, for having me.
Well, thanks for letting me be here, and go out and figure out where all your data is coming from and where you got it hidden, and make sure your SCADA server is where you think it is.
All right. Thanks, everybody. Have a wonderful afternoon.